Questions on complex numbers, or is everybody just comfortable now? Jennifer, is that a hand up or not? Okay, what's the question?
Number 30.
3-0. Okay, let's see where we are on number 3-0. No, I went too far. There we go. 3-0, sort of sandwiched between. So what we have on number 30, I need to get that so it's not quite so right. Let's try that. Right? 21 plus I over 4 plus I. Is that the one you want? Okay, so I have 21 plus I over 4 plus I. Let me write what we have up here. And what we're wanting to do, get rid of the I in the denominator. So we're trying to get this in the form of A plus BI, not the quotient of two complex numbers. And so the argument, we're supposed to do this. The conjugate of the denominator. So with that as a first step, the question is then, what will I have in the denominator? And the obvious answer is something without I. I want to eliminate the imaginary part in the denominator. So I'm going to have 16 minus a minus 1. Is that part okay? Because that's 16 minus I squared. But I squared is minus 1, so that's going to become 17. In the numerator, I have the 84, 4 times 21. Then I have the 4i minus 21i. We did this yesterday, and we got negative 17i. And then we had minus I squared. But the I squared was negative 1, so this became 85 minus 17i over the 17. And yesterday we did factoring. We pulled the 17 out. We had 5 minus I. The 17 canceled in the denominator. We get exactly what we did yesterday with 85 minus I. So that should feel a little bit like deja vu. Now, one of the things that is talked about in the text, and I haven't said much about this, and it was part of the homework last night. If you get this answer from doing a division problem, what we're saying is if you divide 4 plus I into 21 plus I, you're supposed to get 5 minus I. And so you would have a check on this. So if you want to check your work, just as it's done with the arithmetic of real numbers, if I multiply this answer times the divisor, I should get what I had in the numerator. So the check is to take the 5 minus I, to multiply it times the 4 plus I, and the question is, and we need to bring that over there a little bit more so we can see the right side there, then this should be, the answer should be the 21 plus I. So if I multiply this out, I should be able to make it work. So I get 20 here. Then I have minus 4i plus 5i. And then I have minus I squared. But that's 20 plus I plus 1, which is 21 plus I. And I have exactly what I was supposed to get. So the argument, we talked about an arithmetic of real numbers. Here we're talking about an arithmetic of complex numbers. And we can check division in exactly the same way we checked it when we were doing it with real numbers. Any question there? And that's one of the things you were supposed to get out of the solutions from yesterday. And then one of the things that came up yesterday at the end of the hour was talking about, and I didn't take time to do this, during the actual presentation. It came up as a question after class. But we have the square root of negative 18i. And so the question, in something like this, what are we really arguing? Well, we're saying, no, I didn't do that right. It was the square root of negative 18. Sorry about that. That would be another expression we could have. But in this case, we just have then the square root of negative 1 times the square root of 18. And we separate it then into an imaginary value, the square root of minus 1, which we call I. Then I have the square root of 18, and I'm expected to simplify that. Now the 18 can be written as 9 times 2. So I think of this as I, the square root of 9, the square root of 2. Then we get I times 3 times the square root of 2, but it is considered awkward. So we typically put the 3 in front, the I next, and then the 2 here. And this brings up another question. Let's say I have the square root of 2, and I have an I. This is also brought up in the text. The problem with the way we do radical signs is we often sort of let them trail off in the distance, and we don't get very careful about it. One way is to be very definitive and sort of drop that little view there and say, okay, now that's a little bit clearer. But how do you avoid the problem? You put the I in front. And that's considered better form. Now, I mentioned yesterday about problems where, I think it was yesterday, I'm recalling the lecture content, but we talked about taking an equation like this and arguing that there were 5 solutions to that equation. They were, in fact, I think I'm going to do, no, that'll be okay. If I take that problem, I should have 5 solutions to it, and that those 5 solutions would be on a circle, a unit circle. They would be looking like a pentagon. And with that in mind, the question, what are the forms of the 4 solutions here that are going to be complex numbers? And there are times when we get expressions that might involve the square root of I. Okay, now to that extent, if I took the square root of I and then squared it, I would get I. So if I take this to the 4th power, then I have the square root of I times the square root of I times the square root of I times the square root of I. But that's I times I, but then that is I squared, and therefore that's minus 1. So I can say that one of the 4 roots, 4 fourth roots of minus 1 is going to be the square root of I. So what I'm saying is if I take the 4th root of negative 1, I'm saying one of those values is the square root of I. Because when I take that to the 4th power, I get negative 1. By the way, another one is minus the square root of I. So it is possible to have the square root of I itself. So it's not that outlandish to come back here and say, maybe the I should be inside the square root sign. And so that's why we prefer, if it's clear, that I should not be under the radical, put it in front. Just a form of notation. Jennifer, that was extending your question by a bit. But is there any other question on the homework? Okay. Then let's collect the homework from that section. And that covers the new material that we had yesterday, where we were talking about complex numbers. So we'll take that homework in. Thank you. We'll set it to the side and I'll pick it up later. We have a final coming up. Yeah, I know. Like this is a
Surprise.
surprise, right? Big surprise. One of the questions, how are we going to, just over just on the table, they'll be fine. One of the questions is how is the final going to be set up? And so, Ernie, I'm going to go to the sideboard in that as we talk about it. Sorry. But you have new material that we've just done in Chapter 10. Now let's try to summarize that a little bit. There's a review set of problems here that I wanted to look at today. Part of my intent was to provide some review of Chapter 10. But if we look at what's done on page 620, go to the document camp. We have in 10.1 the quadratic equation. Then in 10.3 we have a discriminant. We have complex numbers in 10.4. And then in 10.5, if I sort of slide over there, we have the parabola. Now the question, what have we done in Chapter 10 in sort of view of what's listed there? Because as I've been going through in the last hour, and I've been looking at what we did in Chapter 10, it was clear to me as we go to the sideboard now that what I was doing was not necessarily exactly in the same form your text was doing. So first, in terms of this chapter, thinking of what we're talking about getting ready for a test, you were solving a quadratic equation. And in a sense, there were two key parts to this process that were new to you. One was completing the square, and the other the quadratic formula. So we had completing the square. Guess I should put the in there. Completing the square and using the quadratic formula. Now, in a sense, I went beyond that, of course, because in addition to just using the quadratic formula, what did I ask you to do? Also develop the quadratic formula. So use and develop. And then what did we do with completing the square? Out of that, I'm going to kick down here a subcategory of graphene. And certainly we had as a part here parabolas using completing the square. But I extended that beyond just parabolas. We did what? So I could put not only parabolas here, I could put in parentheses conic sections. So we extended some of these ideas in a very definite way. Rather than just showing how to do the process called completing the square, we used it as a tool for graphing parabolas and conic sections in what we called translation. Of the vertex. Really the axes, but we translated the vertex of a parabola, and that's where you started looking at where the new vertex was, and then you talked about standard position and getting the equation for me. You started with an equation and then you graphed the parabola. So we went both ways in that. Equation, so you start with the equation, go to the parabola. Start with the parabola, go back to the equation. I wanted you to go both ways in that. We talked about how to complete the square, And then we talked about using that idea to develop the quadratic formula. And then how do you use the quadratic formula? Somewhat, in a way, superfluous to this general process we went through here was solving a quadratic equation using the square root property. So somewhere in here, I guess I could put out of this came using the square root property. But it was not, in the scheme of things, as important as the other things we did there. Now, I think it's appropriate to consider doing a problem on our test that's coming up, in which you go ahead and you solve an equation using the property. The example there, just to remind you, was where we had x squared equals 2. And we said then x is equal to plus or minus the square root of 2. We went through that considerably. And just as a reminder, that brought us to the idea of extending or expanding the real number system to do that. Now I'm going to come off there, and we've got a call coming through. So let me come back up here, Ernie, and try to catch that. Okay, and we just have a blank line, so somebody
Missed it.
didn't make it. But again, we had the square root of 2. And we argued that having the square root of 2 allowed us to go ahead and deal with the real numbers. Now, I mentioned earlier that that came out of a classic problem using the diagonal of a unit square. And that's where we extended our number system. That was our justification, if you will, for going into the real numbers earlier. Now, Ernie, coming back to that equation at the top there where I have x squared equals 2, that'll be fine. The idea was that in order to solve that equation and have two solutions, because this was the equivalent of x squared minus 2 equals 0, that I needed to introduce a new number system, hence the real numbers. And then we asked, as we did this kind of problem, what happens as I go from x squared minus 2 equals 0 to x squared plus 2 equals 0? The argument being, I'd like two solutions here also. And so when we then isolated the variable on the left side, trying to use the square root property, this forced us into an interpretation of the square root of a negative number. And we just talked about that on the front board, where this then is argued as plus or minus I, the square root of 2. So this extended from up here, where we had need real numbers, I guess I should bring that only up here in, up to this far, I guess, to down here where we need what? To do this, we need the complex numbers. So part of this chapter was to extend our idea of a number system from reals to complex numbers. And of course, what your homework was last night was to work with the complex numbers. Now, I thought it interesting, we've commented in a way how we've come full circle. We started with the reals, we ended up with the complex numbers. If you will remember, there was a graph, a picture of the reals that I asked you to be able to reference on the first test. Now, we're going to leave this for a minute, and I'm just going to walk off camera from here and leave that on the screen, because there is a similar picture in what we have.
Page 600.
What number?
600.
600. I was not quite where I needed to be. There is a similar picture to where we started at the beginning. And as we look at this graph now, this picture, if you will, and that probably needs a little better contrast. Okay, that's looking pretty good. We just had the reals before. We just had this portion in here. And now we have a larger group in which we have the imaginaries that involve I, plus the reals, and that together gives you the complex numbers. So thinking of that, in the reals, we have the rationals. A subset of that is the integers, and a subset of that is the wholes. Subset of that, the naturals. So we have this big cluster right here that I'm running the pen around. And then we just add in what? The irrationals over here, and suddenly we have the reals. Well, then we have this big cluster here called the reals, and then we just add one more column called the imaginaries, and we get to the complex. So to that extent, I'm going to want you to go ahead, and I want you to be able to reproduce that picture in some reasonable way for the last exam. So what we've done is come full circle, as I say, starting with the picture. So whether I say graph up here or slash picture of the reals, then we are going to come back and finish out with graph slash picture of the complex numbers. So sort of finishing where we started. Now, if we, and maybe let's now sort of pan back a little bit to the left here, if we could, Ernie. Thinking of what kind of problems I'm going to ask you. Well, certainly, need to pick up all the way. We need to solve a quadratic equation. Now, how have we been solving quadratic equations? What are the techniques? Quadratic equation, x squared minus 3x plus 2 equals 0. How can we solve a quadratic equation?
Factoring.
Okay, factoring. So we can do a factoring. What else can we do?
Complete the square. Complete
the square. Or quadratic formula. Or, I'm going to just put a radical there, square root property. Now if I look at those four ways, I could give you four problems, saying I want you to illustrate each technique. So we could think of each of these, put a check mark next to them, giving you four problems total. Then, if I talk about graphing a parabola using completing the square, I can put another check mark there because that would be another problem. And then developing the quadratic formula is another problem. Then I could talk about equations of standard form. That was something we talked about. The standard form of conic sections. That's certainly a problem worth talking about. Another problem there. Now we can sort of pan over here again more to the right now. To that extent, we have 1, 2, 3, 4, 5, 6. And the idea of starting with the graph and going to the equation. So we, in terms of this translation of axis, part of this is graph of parabola to equation of parabola. That, again, another problem that I think merits looking at. So we're at 4, 5, 6, 7, 8, and then if I come over here to this graph or picture, that's 9. So it seems like we can have 10 for 10. So we could think of 10 problems from chapter 10. That seems like a reasonable number to anticipate. Have I structured for you the kind of problems that we're talking about? And one thing I didn't do, we have 9 so far, and of course the 10th one is what? The arithmetic of the one we did today. Complex numbers. So there's easily 10 different problems that you should be able to do. Yes?
Can you put in a couple more arithmetic problems? Scratch the graphing of the parabola.
You mean that you would ask me
Yeah.
to take this material from last night and use it to replace some of the more exciting, interesting, and delightful material from before?
Complex.
The complex material from before. No.
I didn't think so.
You didn't think it would happen, really, I know. Does that give you an overview of what I'm expecting you to do from chapter 10? That's 1/3 of the test.
Anything in chapter 10.
Okay, so then the question. What are we looking at for the remaining part of the test? Because I'm anticipating something here around 30 problems. So we have 10 problems from chapter 10. Then I think we can look at 10 problems. That's my first reaction, is 10 problems from each. Oh, that's interesting, because if I do it from each, we've had 3 exams, haven't we?
Mm-hmm.
We'd be a total of 40. So 10 problems from each of 3 midterms. I think that's what you should count on. Now, I may cut that back a little bit, but thinking of a 40-question test in 2 hours, and I might cut it back to 35 or something, but I would certainly look at 10 problems from each of the 3 midterms. Okay, so let's see if we can break this out by each test. So test 1, test 2, and test 3. Well, probably the most recent of those is test 3, right, in terms of what we just did. Now, what was the material? It was certainly before chapter 10. That was the new material. It was 7, 8, and 9? So this was chapters 7, 8, and 9. Now, some of the things we did in there: systems of equations, systems of inequalities. So we have systems of equations and inequalities. That was a biggie. And of course, graphing. And we have the slope-intercept form. So this was graphing lines. That's sort of a generic area. Broad brush strokes, graphing lines, slope-intercept, point slope. So we had SI, slope-intercept form, comma, standard form, SF, point slope form, PS. We had solving a system of equations using graphing, using substitution, using elimination. We talked about determinants. What have I left out in that 7, 8, and 9? If you look at your text.
The distance between points.
Distance between
Really,
points.
you didn't have to bring that up.
Okay.
I did, because I...
That's the one that caught you in the test. Distance between points. Have I left anything else out from that category? So what we're trying to do is just organize where we've been, what we've been doing. Because part of what we need to do tomorrow
Functions.
and Thursday is look at this idea of a review from what we need to cover. The functions, an important part of that. So I left any, and of course we have word problems with systems of equations. So,
Fractionals.
okay, the idea of fractional exponents. So we introduced an extension of all the rules we used for regular exponents to fractional exponents.
Radicals.
Yeah, that includes radicals and fractional exponents.
Okay.
Good point. That cover it?
I think so.
Okay, if we were to look at that in terms of what kinds of questions might be involved, certainly looking at slope-intercept, point slope, standard form for equations, and graphs. I think if you look at that list and started talking about you wanted to solve a system of equations, choose the method, that's certainly one problem by itself, graphing a line, another problem by itself. Looking at fractional exponents and radicals, I think you could come up with 5 problems without even working hard that would be just general kinds of problems without too much difficulty. So getting to 10, that might be a little bit harder, but I would look at the test and say, if I had to select 5, what 5 would I select that would be good representative problems, and then try to push that to 10. But 5 should be very easy to do, 10 a little bit harder, somewhere in between there. Now, one in between for me is to try to go like 7 problems from each of the first 3 exams, and then 10 of the new ones. And that would put us at like 30 or 31 problems. So that's bottom line, minimally. 7 problems from each of the first exams. Whether I try to push it to 10, I think if you look at those tonight, one test, and this might be certainly one way of doing our review, saying tonight, go through this test 3, and we spend time on that tomorrow. What we would really need is 3 days to do that. So that's perhaps one nice way of thinking in terms of test 3. Minimally, select 5. Maximum, 7, a third of the problems. I don't think I want to try doing 10. Just my first reaction to end up with 40 questions in the test for 2 hours might be a bit much. But let's go back to test 2 now, and let's try to break these up in a similar way. Now this took us up through 3 chapters of that test. In test 2, we had chapter 6, chapter 5, and I think we went back to 4, 5, and 6. Was it 3 chapters in the second test? So we had 4, 5, and 6 there, where we had 7, 8, 9 here. And of course, in the first test, I guess we can fill that in, chapter 1, chapter 2, and chapter 3.
First sections from chapter 4, but okay.
So roughly speaking, in a rough sort of way. Now, what do we characterize as 4, 5, and 6 from chapter 2? Just trying to get an overview of that. Okay? What were some of the things? I need to have it loudly enough I can hear it.
Rational expressions and complex fractions.
Okay, so we had rational expressions. Complex fractions. Okay, what else?
Negative exponents.
Negative exponents. So that's interesting in the sense we, on the first test, had positive exponents. Second test, negative exponents. Third test, fractional exponents. Okay, so that was sort of a natural progression. Here we simplified rational expressions, and here in a sense we simplified what we might think of just polynomial expressions. Here's a case where you added and subtracted binomials. In a sense, you had a bit of an arithmetic of polynomials in the first test, because you multiplied binomials and you added binomials and you subtracted binomials and you divided. So polynomial expressions and then the arithmetic of polynomials. Now, when we come to the second test, we were heavily into factoring, correct? So this was a biggie here because we talked about special factorings and the argument that you had a difference of squares, a difference of cubes, a sum of cubes, and the general idea of taking a trinomial and factoring it. And did we solve equations here by factoring at that point? Second degree equations, or did that wait until the third test?
Solved, yeah.
Yeah, so we solved by factoring.
Squared, yeah. And
So solve QE, quadratic equations, by factoring. And then, of course, we extended that as we went to test 3 by going to completing the square. Okay, what else am I missing here in chapters?
Inequalities.
What?
Inequalities.
Okay, we had,
And graphing those on the line.
okay, so inequalities, like x less than 3, or did we have quadratic inequalities?
Well, we had x squared minus 4x minus 5 is less than.
Okay, so we had quadratic inequalities. I maybe need to go ahead and under this, let me do it this way. This was chapters 4, 5, and 6. We'll just do this to save space. And then we had quadratic inequalities. And it's interesting because what did I do just this last week? We talked about looking at those as parabolas. So quadratic inequalities and solving quadratic equations. So we solved the equation and the inequality for quadratics. What else do we have in test 2, chapters 4, 5, and 6 in my list here?
Division of polynomials.
That occurred in 4, 5, and 6?
Long division and
Okay, so division of polynomials. Now, is this where we introduced multiplication with binomials, taking the products and such, or did that happen?
multiplication of polynomials, yeah.
Okay, so multiplication of polynomials. So in essence, we limited ourselves in the first 3 chapters to just addition and subtraction. So this is multiplication of polynomials. So down here, I guess I want to say plus and minus. So just adding and subtracting of polynomials in that first test. Where do the word problems really get introduced? We had those in the first exam, right?
Yeah.
So a heavy emphasis on word problems in that first exam.
Yeah.
And then, of course, we introduce word problems in each of these, but the first emphasis on word problems occurs in chapters 1, 2, and 3.
And we also had scientific notation.
Is that in chapters 1, 2, and 3?
That's chapters 4.
Chapter 4. So scientific notation needs to crowd in here somewhere. And that's maybe best done this way. Scientific notation. So just have that as a category there.
And least common denominator.
Okay, that was in...
6.
Okay, but we're using that for solving equations, correct? Multiplying, simplifying. Otherwise, when we get to complex fractions,
Yeah.
that involved the LCD. And we used that also as a way of simplifying solving equations. Okay, let's backtrack now all the way to 1, 2, and 3. So let me get some more space here. Chapters 1, 2, and 3. Here, big emphasis. Properties of the real numbers. We started there, and I'm going to come back in the final to the properties of the real numbers. So I want you to be able to do that. We learned how to work with positive exponents and polynomial expressions, simplifying, word problems. What am I leaving out there?
Finding slopes.
This is in 1, 2, and 3?
Ratios.
Proportions.
So ratio and proportion, slope of a line, and I introduced at that time the slope-intercept idea although it was presented later. So slope,
Just slope.
do we graph also?
Graphing linear equations in two variables.
Yeah, so graph slope and just for the first time graphing with a set of ordered pairs. So slope and graphs. Now, interestingly, that becomes a big issue in chapter 7 again, because we talk about graphs there. And we don't have too much going on, I think, in test 2 on graphs. That was pretty much done in the test 1. So a big issue of graphing there, coming back and being a part of test 3. Am I missing anything else in test 1? This got a little bit more crowded than I planned.
Absolute value, I mean, because one of the questions on your first test was
Okay,
get the
absolute value.
definition for the absolute value of x.
Well, I think I will just, to do that, talk about the absolute value of x. I'll just put it in symbols. That was an important idea. It's one that I feel very strongly about. Definition of absolute value needs to be part of that. Okay. Anything else from the first test? Okay, what I think I'm going to do, Ernie, is I'm going to step off here and try to zoom in just a little bit tighter on each one of those. And as you do that, maybe people watching the video are going to get a little better idea of what's happening there. So if you want to zoom in on test 1 a little bit tighter, let's just look at the monitor together. Real numbers, ratio and proportion, slope of lines, graphs, positive exponents, polynomial expressions are introduced with the idea of adding and subtracting them, and word problems, and absolute value. Okay, let's slide over a little bit to test 2. In test 2, 3 more chapters. We had quadratic equations and inequalities, multiplying and dividing polynomials, and of course the biggie there was factoring and negative exponents, the complex fractions. Then as we slide over to test 3, a little more recent material, we had systems of equations, inequalities, graphing lines, the slope-intercept, the standard form, the point-slope form, the distance, fractional exponents, and then at the top we have what? Radicals. Okay? So that's the idea that's involved there. Just go up, stay with where you are. But the idea in the 3 tests, that's sort of the overview of where we've been. And I know it can be overwhelming, maybe even a little bit intimidating. But if you break it into pieces and try to look at it from that standpoint, I'm hoping that we can put the pieces together. So now, what we're going to do at the time we have at the moment is ask, what's your choice of topics that need to be done? So we have some idea of group effort, what we'll be doing as we go through a review. The first question, do you want to start at the end with test 3, or do you want to start at the beginning with test 1? Do you have preferences there that appeals to you? No preference, I'm getting out of that.
I have a question first.
Okay, question first. Maybe that'll help clarify.
Since the first 2 tests, we've learned a lot more. So
Right.
if trying to solve a simple one from the first questions, we sort of make it more complicated because of what we already know. Am I making any sense?
Otherwise, if we go back too far, it's sort of redundant because it incorporates much of what we've done. Is that what I'm getting?
Well, I guess it's more of a thought than a question.
Okay, let's try again.
I mean, from the first chapter, if we go beyond what you're really wanting, you're saying to solve it, and we solve it from a way we know
Okay, I see what you're saying.
now.
More recently.
If I were to give you, from the first chapter, a problem in which I ask you to graph the equation of a line, and all the intent there was, here are 3 points. Plot the points, draw the line.
Well, if you can say it just like that.
As opposed to, here is the equation, and you decide you want to do solve for y, get the slope, get the intercept, and plot the line. And you're basically saying there's a conflict there, because in one sense, at the beginning, we'd be focused on a very trivial problem, and the next is more sophisticated, so how do you determine what you should do? Then I have to be pretty darn direct and say, here is the equation of a line. Find the 3 points, plot the 3 points, and draw the line. That gets you out of that quandary, correct? Mm-hmm. But at the same time, it also gives me a way of covering content in 3 exams. I could give you a problem and say, given this equation, choose a method of your choice to plot or graph the line.
Okay.
Now, that covers a host of material, from slope-intercept, point-slope, to intercept form, to just finding 3 ordered pairs, 2 to get the line and 1 to check yourself.
Right.
I think I'm going to have to provide a certain amount of free choice for how you want to approach certain problems. And in the same way, if I say, here is a system of equations, find the solution. Okay, you have 3 or 4 different methods. If I want to be very specific, I can say, use substitution to solve the system. And I'll try to provide that clarity. But back to my question.
Okay.
Where do you want to start in our review tomorrow? Should we focus at the beginning in test 1 or at the end in test 3? And then I'll make a similar choice for Thursday.
For the test, are you going to start from the beginning and go to the end?
I don't know if that question came through
Or are you gonna
on the
shut
microphone. Am I going to start on the test earlier material and chronologically present the questions so that at the end you know you're at new material? I haven't given thought to that yet. I haven't written the test yet. So my best answer at the moment is I don't know. But I gather your question would suggest that would appeal to you.
Oh.
Start at the beginning and go to the end in sequence. Jennifer.
I think we should start in the middle.
I gave you a choice, beginning or end, and you want to start in the middle.
I was thinking.
Do you have a defense for that?
Because the first part, we can just review. It's simple stuff.
Okay.
Now we're
At the end, we just did.
So we just did the last part, so you took the one I didn't give as a choice, and I'm seeing some support for that. So you would like to come back to the material in chapters 4, 5, and 6 as a beginning point for tomorrow. And I saw 2 other people nod in approval.
Sure.
Okay, we're getting a consensus. That wasn't even a question I allowed, and you chose it. Okay, so what we will do is focus tomorrow on the middle.
Because
It's a
that
little
was
bit like Goldilocks and the 3 bears. This is too hot, this is just right. So we will focus on 4, 5, and 6. That's been determined. And then on the basis of that, maybe we can make a similar decision for Thursday. Of that material, how do you want to approach this? Reviewing it and then coming with specific questions? Or do you want simply me to go in fast motor speed and present 3 chapters in 45 minutes?
a combination of both.
Combination of both.
Oh.
Oh,
I mean,
okay,
if we
Michelle.
probably should go in fast speed Thursday, chapters 1 through 10,
But what about tomorrow?
in 55 minutes.
Tomorrow's Wednesday.
I know, just a last minute review. on
Okay,
Thursday.
so you want the overview on Thursday possibly, but let's go back to tomorrow. Jennifer, you suggested the middle part, so what is your approach to that?
I think we should review, and then questions will come up throughout the review.
So let me just sort of jump into it.
That's what I meant.
With complex fractions, maybe the quadratic equation by factoring, looking at negative exponents, complex fractions. Okay, so an overview first, and then open the door, Pandora's box, and hope we close it back up before the end of the hour.
Yeah, we can just,
Okay, so in your preparation for that, will you focus on test 2? looking at problems there, and you may end up coming in, and I'll leave this as an option. If you focus in chapters 4, 5, and 6, looking at the questions in test 2, and you come in tomorrow and say, I've got 5 questions I need answered, then we'll do it that way. If you've looked at chapters by the test now, and you say, hey, things are okay, let's just take an overview, then I'll be willing to do that. So I'll leave that open tomorrow. I think your obligation tonight, and I don't intend to collect any papers tomorrow, but your obligation tonight would be go back to test 2, try some of the problems. See if, and I think one of the things that comes up here that's inherent in some of Jennifer's defense of doing test 2 first. I would hope that as you look at some of these topics now, that they don't seem quite as frustrating when you go back and look at them and you say, wow, wish we could have had those now in the test, because it's a little bit like driving. You learn to drive, and as you drive just in a parking lot, it's scary as heck. Then you got on McHenry Avenue the first time, and that was panic. Then you went on the freeway and nearly died just from the fright of it. And now you go back and drive on a parking lot and say, hey, that's easy. So I don't know where you're going to be as you go back and look at this. I'm hoping it doesn't seem as traumatic as it once was. Well, I'm sure Ernie has found some soothing Hawaiian music to make you less panicked, less anxious. So what is your selection, Ernie, from Is?
Somewhere Over the Rainbow.
Okay, Somewhere Over the Rainbow. The Judy Garland song, but done with the Hawaiian twist. Have a pleasant day. We'll continue our review tomorrow.